Okay, so today what we're going to be working on is the multi-system of equations. So I'd like you to put me on pause and do the try this and come back and check your answers. Okay, so for the first one it says to multiply the equation by 5. So we get 10x plus 15y minus 5z equals 35. Okay, and number 2 is adding the equations together. So I have 3x plus negative 3x is 0. Negative 4y plus negative 8y is negative 12y. 7z plus 2z is 9z. And that equals 7. Okay, so what we're going to be working on is multilinear systems, and we are going to be using an elimination method. It is an elimination method with more than 2 variables. The process that we'll be starting off with is called Gaussian elimination. Gaussian elimination is putting the system into row echelon form in order to isolate one variable. Row echelon form is a stair-step pattern with coefficients of 1. To get the equations in a stair-step form, we will be using elementary row operations. Row elementary operations are interchanging 2 equations. You can multiply an equation by a non-zero constant, and you can add a multiple of one equation to another equation. Okay, so all we're going to work on tonight, is just doing some row operations. Then tomorrow we'll actually start solving a multi-system of equations using Gaussian elimination. Alright, so number 1 says to swap row 1 and row 2. Alright, so this would be the first one would be row 1, the second one would be row 2, and the third one would be row 3. So I want to swap row 1 and row 3. So row 2 is going to stay the same. So row 2 is going to stay 2x minus 3y plus 2z equals 9. That's row 2. And I'm going to swap row 1 and 3. So row 1 now becomes x plus y plus z equals negative 3. And row 3 becomes 4x plus y minus 3z equals 11. Okay, so the next thing we want to do is we want to multiply row 1 by negative 2 and then add it to row 2. Okay, so now when you add 2 rows together, the new equation that you get becomes the row that this one is. So it's the second thing you're adding. So I'm going to get a new row 2. Alright, so if I'm going to get a new row 2, that means row 1 and row 3 are going to stay the same. So I'm using these here. So I'm going to rewrite row 1 because that's going to stay the same, and I'm going to rewrite row 3 because that's staying the same. So row 1 is x plus y plus z equals negative 3, and row 3 is 4x plus y minus 3z equals 11. And on the side over here, I'm going to do this operation. So I'm going to multiply row 1 by negative 2. So it's going to be negative 2x minus 2y minus 2z equals negative 6. And I'm going to add that to row 2, which is 2x minus 3y plus 2z equals 9. So this I'm going to add these together. And the new thing I'm going to get, the new equation is going to be row 3. Those cancel out, so I get negative 5y. And then those two cancel out, equals 3. So that's going to be my new row 2. Row 2, sorry, I wrote row 3 here. So that's new row 2, sorry. So that's negative 5y equals 3. Now what I want to do is I'm going to multiply row 2 by 3 and add it to row 3, which means I'm going to get a new row 3. So if I get a new row 3, that means row 1 Row 1 is going to stay the same. So row 1 is x plus y plus z equals negative 3. And row 2 is going to stay the same, which is negative 5y equals 3. So on the side, I'm going to do 3 times row 2, which is negative 15y equals 9. And I'm going to add that to row 3. And row 3 is 4x plus y minus 3z equals 11. So when I add them together, I get 4x minus 14y minus 3z equals 20. So that becomes my new row 3. So this one was row 2 in here. So my new row 3 is 4x minus 14y minus 3z equals 20. Okay, so that's it, and we're going to start the whole big process tomorrow. Have a good night.